what's going on YouTube? So I have no idea what happened. I don't know why my scene is all messed up right now. It's very different than it usually is. It's not just that the iPad's not airplaying, which is on me. Like I can start airplaying the iPad, but my camera, my center camera, my live camera is all weirdly centered. I think it's her fault, dude. I think that she did it somehow. I certainly didn't do this. I'm actually really, really baffled about this. Like, why in the world would my scene have gotten so messed up? She's so proud of herself. She just wants to cuddle. Ah, you're so smart. My wife and I have a new joke that she's a super genius. She's just like an actual super genius cat. I'm used to thinking that she's just like really, really dumb. We've always just joked that she's just like the stupidest cat in the world. But recently I've been thinking, actually, no, I think that she's a super genius. She's a super genius. Hey, what's up, Heidi? What's up, Amelia? Gerson Franklin, how's it going, everybody? So I don't know what happened. I don't know why my scene is so messed up today. She's so cute. She's a super genius. Super genius Loon! She knew that if she messed up my scene, and I don't even know how she would accomplish that. I didn't do this. I don't know. There's no... I don't know. Maybe accidentally I clicked the mouse and dragged without realizing. Oh, you know what it probably was, now that I think of it? Oh, what probably happened is I was waking up the computer with my mouse, like clicking and shaking the mouse. Oh, okay, this is what happened. Yeah. Like I clicked the mouse and I shook the mouse and accidentally dragged while I was waking up my computer with my Bluetooth mouse. That's what happened. Super genius Loon. Or she did it somehow. She is so cute. She is. What's up, everybody? I hope you're having a great day. It's another day where we're going to be practicing mathematics live, just hanging out, chilling. This is not a course. No way. No, this is not a course. Don't even trick yourself for a second in thinking that this is the course. But today, I hope I will be filming, actually, episode 7. Today we will be uploading or filming live episode 7, and you all are going to help me finish my lecture notes. Yeah, I'm excited. So today my goal of this stream is to finish my lecture notes on logic, on intro. We're going to, nice to listen in while I work. Heck yeah, that's the goal. I want this to be like math radio show. John's probably live at this time of day. He's probably live practicing guitar or practicing math. And, hopefully, ideally, this can be something that you can work to. So let me know, everybody, please. That's kind of priority 1 for the streams. Obviously not for the Blue Thumbnail main series. That's a different thing. But for the streams, I want this to be something that you can half listen to while working. Kind of like a radio show. I was a college DJ, dude. I did, for 6 months, me and one of my roommates hosted a college radio show. And it was fun. I really enjoyed it. So, there's a bit of background, bit of lore. Hey, what's up, Ming? Either I did this or Luna did this, and I still choose to believe that she's a super genius. She's a super genius kitty cat. So I was surprised. I just got started streaming and my scene is all messed up right now. What kind of foundations? What do you think? Hey, ow! Look! What are your thoughts? What do you think I mean by that? Because the answer is yes. The answer is both. We're in Foundations Week. Foundational basic math, pre-calculus. Hey, and Stucky, what's up on Twitch? Holding it down over there on Twitch. I think people say that Twitch subs are actually the most valuable. So thank you and Stucky for helping me build my future empire. So thank you. Thank you for holding it down over there. I saw your comment and Stucky on Leo's video. By the way, shout out to Leo. His video is phenomenal. I finished it last night while practicing scales. Super good. I just really, really, really enjoyed it. Hey, Levi. Good to see you. Guess I'll join in later. Why? Why? Oh, that Foundations? Oh, no. So Foundations, it's yes. But actually today is a little closer to the secondary meaning of Foundations, actually. So today I'm going to be talking logic and getting more detailed than laying. So I assumed, I'm slowly reacting. Dude, I'm very slowly, this is a reaction stream, I'm very slowly reacting to this book in real time with you all. Slow, but one chapter, one section at a time, I'm giving my reaction. Like, is this how I would teach Intro to Proofs to a high school audience? And I'm a little, I've got mixed feelings about the logic section. I have some mixed feelings. Yeah, actually, Lockheed, in particular, if you could stick around for 30 minutes, I'd actually really appreciate if you could. Okay, so let's see. If I do this, y'all can see the chat, and I kind of want to duplicate it. I kind of like this scene, actually. I'm just going to call the scene All Messed Up. Okay, but now let's go back and let's fix it. So I will be working on Foundations. Yes. The answer is yes. Foundations. Where do I like it around here. So, I'm actually quite annoyed about this because, my scene is, so hyper specifically, placed everywhere to... I think that the iPad's probably not different. But anyways, I'm going to be finishing my lecture notes and hopefully filming episode 7 here live with you all. Because it's very important for me to try to do it live so that I can save time and I don't have to spend all day long doing YouTube stuff because I have better things to do. So to me, it's very important to try to get time efficient. I want to be able to, and it takes work, it takes practice, it takes a lot of work to get there. I want to be able to do everything here during the two-hour practice session. That would be a dream if I could just get everything done in 2 hours. I don't want to be practicing math for more than 2 hours a day, actually. 2 hours? Yeah, no, good luck. It's been 5 hours recently. XP. I think that's a tongue sticking out laughing emoji. But you might, and Stucky, you might be meaning XP. I'm gaining XP. I'm gaining experience points with all these crazy-ass 5-hour streams. How much time do you spend on math each day, off stream? Some. Definitely some. And most recently, a decent amount. My wife and I have... She doesn't want me ever talking about her, but... I have been going to cafes recently and studying. And it's really nice. Sometimes I'll literally leave my phone at home. I'll leave all my electronics at home. And I try to pretend that I'm Gauss writing on paper by going to a cafe and just frickin' working on math on paper. Get a yellow notebook. I'll earn $1. Affiliate links in the description. So yeah, recently it's been on stream and off stream a little bit of actual focused work. Because I don't think that you can learn with a screen. That's a bold, exaggerated, hyperbolic claim, but I think overall it's true. I don't think you can learn very well with screens. If you really want to learn something, you should learn and practice it with paper. I'm becoming an old man who yells at clouds on this point. Why does YouTube think a 30-second ad on a live stream is a good idea? Sorry, I got. They're supposed to be doing side-by-side ads. I thought that has started already, because that's supposed to be the solution here. I apologize, man. I mean, $1 a month. Like, it's the lowest price I can set it to. I think that disables. I think that disables ads. Oh, it is side by side, but it mutes you. Well, then that's fucking stupid. YouTube, man. Anytime I think about how many mistakes YouTube is making, I just get actually literally triggered about it, because I joined Google to try to help them fix this stuff. Like, I wanted to become a product manager, helping them build the live streaming platform. And then when I got there, I discovered that they were building TikTok instead. So I have a very deep personal dislike of TikTok. Because, like, I joined this company to work on the complete opposite of TikTok. And then when I was there, I was like, oh, we're building TikTok, actually. Oh, shit. And I, like, barely even knew what TikTok was when I got there. Okay, I thought Sherlock Holmes is a creator of logic since he authored The Science of Deduction. I don't know that at all. I don't know what you're referring to, actually. Yeah, if channel members could confirm whether ads are correctly disabled for you, that would help me a bunch. We've got a good number of channel members, which is unbelievable to me. Yeah. But I don't want to set the culture that everything is ad-free forever, because that's a trap. That's a mistake that creators fall in. So, I mean, if I started getting to a level where I actually was getting private students and people paying, for courses and stuff offline, then I would disable ads and just use this as marketing. But nobody's signing up for like actual paid tutoring, so like I'm not here to give everything away for free. Sorry. Yeah, Sherlock Holmes is fictional. The author is not. But if the ad block software works, I encourage you all to figure out whichever ad block software is currently working correctly. Yeah. Anyways. So apologies. Sorry, not sorry, I guess. We live in an ad-based society, and I hate it as much as you do, dude. All right. So, I'm preparing my lecture notes now on logic, and I think it's just going to be logic this time. So, I want to come back to episode 6. Let's get a similar style here. Copy episode 7 examples. Feedback is a gift. If you all think I'm being like annoying or something, please let me know. I don't have the book. I wish I did. Oh, yeah, you pay for Premium Light. Great. I think Premium Light is so freaking worth it if you watch YouTube a decent amount. I pay for Premium Light, too. I tried to cancel it and go away and just use YouTube less. But, I don't know. As a creator, I have to watch YouTube. I have to watch other people's videos, see what they're doing, get inspired by what other creative people are doing. Yeah, you did logic this week earlier in your intro to proof stream. I saw you didn't even shout me out or anything. I saw like my thumbnail was like in the like first few seconds. So I'm done shouting you out, Ming. I don't block ads when I watch the streams. I have a suggestion/request. Feel free to deny. Look up Insert Maths books of class 789. On top of that, you were shouting out Leo's video. and didn't even mention, even though you promoted your own logic stream here many times and told people to go watch your logic stream. So yeah, I don't know. All right. I don't. Yeah, all good, dude. All good. All good. Insert maths books of class 7, 8, 9. No, I don't know what that is. Probably not. I'm a selfish bastard. No, I get it. I get it. A lot of people are. And really, I'm just joking. I don't care that much. And yeah, I don't want to go down this rabbit hole. But there's just some other people I'm thinking of. Not you. Okay. So, intro to pure math. This is kind of relevant, I guess. I keep talking about feedback as a gift and other things like that. Like, I think it's really important that that's like one of my values, and I just keep emphasizing it to build like a specific culture in my chat, in my stream, in my Discord, and everything. And like a big part of this is the book Radical Candor. So you all might notice like this is like a huge part of culture at big tech companies, like in particular at Lyft. When I worked at Lyft, like they just had the best damn culture. Maybe they work too much on their culture and not enough on the products sometimes, but they had a really, really great progressive culture, and one of their core values was like radical candor, which is this book that came out from a former Google leadership person, and it's all about this idea. You can watch like TED Talks on this and stuff. It's one of those business books that could just be a blog post. But the idea is that people think of like feedback as either rude or kind. Like either you can be direct and an asshole, or you can be kind and withhold feedback or something. But that's just not true at all. Like it's a quadrant. The main quadrant that people think of is probably directness, I guess. Like how direct are you in feedback? And then the other axis is kindness. And like you can be completely kind and direct, and that's obviously the best, I guess, if you're just like perfectly both kind and direct. But like directness is like actionable feedback that somebody can take action on, and you trust the other person is not withholding info and stuff like that. In the top left quadrant, you have low directness and high kindness. I'm going to hold off on that one. The opposite that a lot of people think of is highly direct and mean, or like not kind, right? So I'm going to assign point values. If somebody's rude and not direct, that's just like saying you suck. Like just saying without any other details, you suck, right? Like this is bad. Or not even this is bad, because that's a specific thing. More like you are bad. You are a bad person. I want to be as like black and white as possible. This down here is a 0. Like if that's just not helpful to anybody at all. Personally, I would rather if somebody's an asshole and very direct, I would give this personally like a 70 or 80 points. And then kind but indirect, dude, I think that's pretty awful. Like, I really dislike kind and indirect feedback. Like, the term here that the book uses is called ruinous empathy. Ruinous empathy. Like, if you don't have anything nice to say, don't say anything at all, or something. Like, I just dislike that so much. Like, ruinous empathy freaking sucks. It's worse, way worse in my opinion, than somebody who's like a direct asshole. Because with direct feedback, you can take action, and maybe you hate that person, or you're like, all right, well, fuck you too, and you have like some interpersonal conflict. It's not a great thing, but at least you have something to improve and improve yourself on. And obviously people can be wrong and their feedback can be incorrect as well. But anyways, I just want to like put this out there for everybody. Like, I really personally, like, anybody would say kind and direct is much better than, I wish I had a better word, mean or rude and indirect. Those parts are completely obvious. For me, kind and direct is greater than rude and indirect, and then this is much better than kind and indirect. And kind and indirect is better, obviously, but a little bit better than rude and indirect. So if anybody's curious about this topic a bit more, the book is called Radical Candor. And so you'll see that that's like an important part of my value system. And especially the guitar people know this. People who've been watching me as a streamer for a while already know this, but this time I get to write it on an iPad instead of just saying it out loud. So if anybody thinks that's interesting, please let me know. So that's to say, today I will be preparing these lecture notes, and I would love if anybody has any suggestions of things that I could do to improve this. And one thing that's important to note here, and this was always an important caveat in all the companies that I worked at, is that be mindful that this is a cultural difference. Like, different cultures have very different cultural norms on this. And so it's important for these companies to really do direct training about the fact that feedback is not always an attack. Feedback is like, we're winning together, like we're like on a team together. Something like, of course, this is a gradient. It's not like everything is binary. Like, often the best freaking feedback, like Heidi knows what I mean by this. There's somebody named Renee Izquierdo. I was going to say RI, but I used RI over here. Renee, I had a master class in classical guitar, and it was like the most direct feedback I've ever received from anybody. Like, I just bombed with like stage fright on stage. And he just gave me the most direct feedback. And some people in the comment section and talking afterward, or like at times I felt like, oh, that guy was an asshole. But it's really not true. He was very neutral in his tone the whole way through. He was like perfectly neutral and incredibly direct. Like, unbelievable, 100% direct. And it was like, hell yeah, dude, thank you so much. So, yeah, I hope that you all found this topic interesting in some ways. Let me catch up. Because I think that this is more important than freaking math to talk about this sort of stuff. This is a pro tip, y'all. All right, so sequence-style deduction-based intro instead of truth table-based. Ooh, I don't know about that. What is sequence-style deduction? You're really into your like alternative hipster theory building lock. I'm gonna give a very standard truth table based intro, because it's how I was taught. It's how most people were taught. I don't want to, like, my target audience is not like people who are already pure math pilled. Like, my target audience is people who this is their intro to pure math. I still have my flavor, like I still have my style of presentation that I think that you all will like, but I don't know. I would love to hear. But yes, today is logic. We've already done on reading books last time. I'm preparing my lecture notes today. It would be so great if I could get to the point where literally every single thing I do for my videos is live. That would be... Because I'm just so much more... Like, I'm very interested in efficiency. And we've been efficient on some dimensions, like maybe growing a stream, growing a YouTube channel, building a specific culture in these streams and things, and experimenting there. But recently I have not been very efficient at all about making progress on these episodes and lecture notes and studying math for myself. So, 1 minute ad is diabolical. Dude, I'm sorry, but if you are here every day, like, really consider whether it's worth the cost of a cup of tea to disable ads. Like, once a month, like, if you value your time, like, really think about how much you value your time. If you put a dollar amount to it, like, is your time worth more or less than minimum wage? Right? If your time is worth less than minimum wage, then you logically, rationally should work a minimum wage job or higher, right? But if your time is worth more than minimum wage, I guess you should look for a more appropriate job. But, like, what would you do with that time, like, if you weren't watching an ad? Like, this is just such a eye-opening idea from another book that I would recommend and geek out about, but I don't know. I hope that you all can really think about whether, I don't know. I just dislike the ad-based economy so much, man. I really do. But as a creator, I don't know. There's not really a good alternative until you get to a certain level of fan funding. Maybe not specifically sequence whatever proof calculus that is not truth tables. I just don't think that there's anything wrong with truth tables. I do want to study other alternatives for myself, but not for the sake of this course. I was surprised. Lang doesn't even give truth tables in his book. So I'm reacting to that a bit. Like, I'm actually reacting to that. I'm a little surprised that he doesn't even give truth tables. And I think it's really missing. Like, I feel it's kind of strange to show proof by contradiction, proof by induction, lots of proofs throughout the book, proof that there are infinitely many primes, and not show a truth table. If someone understands how proofs work, they could probably grasp it. Sequent or sequent-based. Chemistry sucks. Chemistry does suck. That's why I turned into a math major, actually. Quite literally. 0 for me. 0 out of 100 of what? I think in math, directness is more important because it's so hard to get feedback in general in math. Absolutely. Yeah, math is... Yeah, you don't want to, like, pull punches in some way if a proof is incorrect. You need to know specifically why. And I don't know. I just love that math is, like, pretty... It's just so neutral all the time, I feel, in terms of... But I've never worked with, like, an advisor. Interpersonal conflict happens all the time between advisor and student. So that's where all that human side happens. But like yeah, no, I don't know what I'm talking about. I'm talking about something I don't know about at all. But like, at least in books and stuff, like kindness versus rudeness. That thought just isn't complete. I'm disagreeing with myself in my own head right now. Let's keep going. Kindness helps getting your message across, or neutral. Neutral is perfectly fine too. Like a neutral tone is... Maybe tone is another word, but... I am awesome and can be more awesome, 100 points. Yeah, truth tables for someone new to logic pretty much ingrains the idea of everything being only two valued, so LEM sounds obviously true. Yeah, the book that I'm working with really calls this out, that there are many valued truth systems and other things. But I like its treatment that the purpose of building different models... Enderton does a really good job about a nuanced take on this, that the purpose of this book is to model mathematical reasoning, like classical mathematical reasoning, and that every model that you build, you need to choose some features to keep and some features to discard. Every model is incomplete, and that this model that this book is focused on does not capture certain features that are valuable in other places. I just don't know. I haven't personally learned sequence style deduction, so I'm interested. Let me put that as a to-do for myself. Okay. We can still teach classical logic. I just don't think that you should teach something non-standard first. I think that that's a pretty broad claim, and I think it's broadly quite true. Like, I don't think that you should teach the non-standard thing and skip the standard thing. I think that you should teach the standard thing and then maybe quickly introduce and switch over to the more modern or non-standard approach. But you should never, as a teacher, I feel, skip the standard treatment completely. Like, you should at least briefly introduce the standard treatment and justify why you're doing a non-standard treatment. It's kind of like bold claims require great evidence, or whatever the saying is, right? Like, if you make a strong claim, you need a good justification if everybody else is doing it one way. So in this series, I definitely wouldn't start out with sequence style deduction. But I'm curious. Like, I might look into it and might do an episode later about it. I'm definitely open and interested in modern formulations. Very much. Levi asks, how do you reply in a way that highlights usernames? You just have to type the entire damn name, which is insane. Like, it's so bad, man. Like, as a product, it's just so bad. Like, as a creator, in my chat box, if I start typing a name, I get a pop-up, and I can click their name. I can click your name from a pop-up. So they've already built the pop-up. Why doesn't it work for the users? Like, I just can't. I don't know. Man. You have to type... Oh, wait. When I type the @ symbol in the first few letters of the username, it auto-completes. That's new, then. Okay, well, then I take it back. That is brand new. They finally implemented that for users. But it might be... What platform are you on, Arad? On the website? Are you on a desktop website? Are you on the Android app? Are you on the iOS app? I really wouldn't be surprised if it's available on one before the others. that's probably what's happening. I haven't heard of that book, Naima. It's different platforms, of course. Oh, you're doing a Unity stream. Let's go. That's awesome. Lomzo Gaming. That's awesome. Yeah, different platforms, I'm sure, is why. Please give the name of your other book recommendation. Okay. For my book recommendation, right? It all depends on your goals. I should create a new note for this. I imagine, Amelia, you're talking about book recommendations for intro to proofs, right? This is going to be a common ask, so let's do it. Intro to proofs. Right now, my primary recommendation is Basic Math by Lang. But you know that. Lang Basic Math. My secondary recommendation... honestly, I would say my secondary recommendation is going to be Galleon, Abstract Algebra. And let's make it clear that I'm ordering these. I'm sorting these in order. Now, there's different purposes. Thirdly, I'd recommend Velleman, How to Prove It. Fourthly, I'd recommend Rosin, Intro to Number Theory. Fifthly, I would recommend Abbott, Understanding Analysis. These are my personal recommendations, and I can only speak of books that I've worked with at least a little bit. Like Velleman, I have not worked through very much, but I've read enough of it to recommend it. I think that is quite good. Rosin, Intro to Number Theory. Please let me warn you all, not. This is a totally different mathematician, Rosin, not Ireland and Rosin. That's a different Rosin, and that's a much harder. That's a much harder book. You want Intro to Number Theory, different Rosin, different number theory book. I know the world is weird like that, and I don't think a lot of people recommend this book. But I think it's good. I mean, that's what my course was taught out of. I enjoyed it. Broadly, I would. It just depends on your goals, obviously, partly. But this first book is pre-calculus. But it's also foundations. It's foundations, like the same proofs on the square root of 2 being irrational, and the proof that the sum of numbers is n times n plus 1 divided by 2, and the proof that I don't know. Why am I blanking right now? Like, all those standard proofs are going to appear in all of these books. Um, the question is, like, what topics are you interested in? Abstract algebra is like a new topic to a lot of people. How to prove it is like a very general purpose, general slash various topics, and it gets into the weeds of really just thinking about proofs in and of themselves. I think it's better personally to learn proofs in context of learning math, in context of actually learning a subject. So I don't know, if you're interested in prime numbers and understanding why some mathematicians think that primes are beautiful, I think number theory is a good place to learn proofs. Now, analysis, I'm just biased against it. But I think that proofs in analysis are not. So this is like theoretical calculus is, I think, an accurate enough way to call this. Calculus. Epsilon delta proofs are like kind of magical. I think that if you tried to learn proofs from analysis, you'd get a certain image of proofs that doesn't translate very well to computer science. And computer science and machine learning especially is one of the biggest reasons that a lot of people are now more interested in proofs than in the past. So you have to learn analysis and that type of proof at some point if you're a math major or if you're really interested in math. But it's not where I'd start. I'd almost remove it from this list, but yeah. If I were to order these, I would put 1 is first, 2 is second, 3 and 4 are tied, and then Abbott, I'd put last. Maybe 1 and 2. It really depends. Yeah. 1 and 2 are tied. Oh, I guess those would still be 3s, wouldn't they? Huh. The first 2 are tied. The next 2 are tied. And then the last one is my lowest recommendation. Okay, I'm behind in chat again, as often happens. Let me catch up on chat. We're talking about book or books I should read before Lang's book. No. Lang's book is for you. Lang's book is for pre-calculus / this one is the simplest, lowest level, even more than the other ones. This one really is for people who haven't done any math in a long time, I think. This is the most accessible because it's math that you're already familiar with. You're not learning a new type of math. So that's one of the biggest reasons that I'm going to recommend Lang's Basic Math to my audience and to people who are returning to math and considering math as a hobby. It's because you're learning something new while reviewing math that you already know. You think you know, but you don't know as well as you think you do. And yeah, just find a PDF and skim through it and find out if it's what you're looking for. Hey, Electronics SP, thank you for being here, dude. Thank you. Honestly, I don't find really great content in last few years compared to earlier sessions that you have done. Sorry, I feel this earlier. Your videos hooked me to watch them completely. Sorry, I apologize. Electronics SP, if you would like to talk on Zoom, about this, I would love to if you wanted to, because I need to be doing a lot of user research right now and understanding electronics SP or anybody out there. I would really appreciate if you could give me specifics, because like specifics are not going to fit very well on in a YouTube chat box, but especially somebody who's a channel member, I think it's really important for me to understand like what you want more of and what you want less of. Because I'm getting a lot more questions in the chat and they're all math related, you know, so it is math. Like I'm talking math right now, book recommendations, but I'm definitely not as like just it's me and two other people in the chat and I'm just working problems. So if that's what people want, like I might just film private problem solving sessions and then upload that, like if that's what people want. But I need to, there's so much noise in the data, like and it's impossible to please everybody, right? Like I don't know, without getting data, without getting feedback, I don't know. It feels like I'm shooting in the dark and just throwing stuff at the wall and seeing what sticks. Like thank you for the feedback. It really means a lot. And so the only thing I can really take action on in there, or like my biggest clue from that message from electronics is that my earlier videos hooked you. I want to know if you mean earlier as in my early live streams, or do you mean my blue videos that came out a month ago? Those are not my early videos, right? Like those are not my early videos. Those are a very recent thing. And if you just want to watch those, I want to make it as obvious as possible, because I think a lot of people are only going to want to watch the well-produced, you know, well-prepared, structured lesson videos. I just want to make it as obvious as I can from the thumbnail and the title and just everything, like the time, the duration of the video, that this is a different series. Like I might have to just create a whole separate channel or tell everybody to switch over to Twitch. I think that's a bad idea, but yeah, extraordinary claims require extraordinary evidence. That's it. Yes, and that's Sagan? I didn't even know that. Thank you. Extraordinary claims require extraordinary evidence. That is the phrase that I was looking for. Thank you, Amelia. Simple book for functions. Honestly, this book, I think. Yeah, coming in late about ads. I pay Google a small fee and they don't put ads on my videos. Yeah, exactly. I pay for the premium light, and it's one of my most valuable subscriptions right now. But I'm trying to use YouTube less so that I don't even need that. Like I'm working on this myself. You're on the web player, and it's definitely not new. It must be that you're on the web instead of, because me too. I'm on the website. It pops up there. It's not available on the mobile apps. That's a thing. The other book you're talking about, something other than Radical Candor. I don't remember what it was. I apologize. It'll come back to me. Sorry for just going on a long rant that you weren't asking about then. Okay. Is it fair to say that your objective of the Intro to Pure Math series is a gateway to abstract algebra, number theory, discrete math, and theoretical computer science? No, not really. I mean, right now it is very algebraic and discrete because those are the foundations in integers and such. But we will be getting to the real numbers. We're going to get to trigonometry and geometry. You asked, what is my objective? It's to learn how to teach and get a job. My objective is to become a high school teacher or, start making like a full-time living off of YouTube. But most likely that's extremely unlikely. yeah, my primary objective is to find a way to study math and teach math instead of going back to tech, because tech is super shitty right now. So it's not a gateway to abstract algebra. I am definitely biased toward abstract algebra, number theory, discrete math, and TCS, but and I'm not shy about sharing that side of math. Like, maybe I'll consciously decide to lean on that more, but it's because that side of math is underrepresented, I think, for people who only have learned math through the American education system. Like, for us, a lot of people think that math is a path to calculus and then you're done. And calculus is the end of math. The calculus is like, and then everything after that is just harder calculus. No, that's not true. In fact, calculus is not the most important math today. The most important math is more discrete. It's binary, zeros and ones, discrete math, which runs computers, and things like linear algebra, which helps build AI. So a lot of people are interested in more advanced math today because of AI, and people want to career shift toward machine learning and AI. And I love linear algebra a lot, so I'm happy to, to teach people linear algebra. Does that make sense? Yeah, I think that this book is intended to be a good intro to functions, and I will give my personal spin. Yeah. You're biased towards analysis for sure, man. I mean, of course. It's just, that's not my target audience. And if I were studying math for myself or pursuing like research math, I would pick more algebraic, discrete math. It's just what I personally find a little more aesthetically pleasing to myself. Or maybe it's the way my brain is wired. There's a funny story, y'all, if you don't know about this. I should set up like a short link about this, but dude, this is the worst drawing of Kohn in the world. I can't draw. Okay. But imagine Kohn. Have you heard this story, Ming? Do you know what I'm talking about? This is math, y'all. The newcomers may not realize this is math. We are talking math here. Does anybody know what I'm talking about? You're starting your first attempt to abstract algebra on my 2.0 channel. Oh, you have a 2.0 channel. You got hacked? Dang, dude. That sucks. Does anybody know what I'm talking about here? About Kohn? Why is Kohn relevant to math? Oh my god, I haven't even thought of this. Remember the Kohn kid from like a couple years ago? Oh my god, that's so funny. Because I knew this Kohn story like 15 years ago when I was a math major. But now there's this Kohn kid who should be like the mascot of this. I'm going to definitely use that in a video whenever I tell this story. Nobody knows this. Or my chat is delayed or something. I'm so interested if nobody knows this. That's amazing if nobody does. Hell yeah. I'm giving it some time, and how many people are in the chat? Is Leo in the chat? Leo hasn't said anything yet. There's 22 people watching me right now, and nobody knows this. Matrices, no. Oh my god. Okay, cool. There's a funny story about mathematicians. You actually have no clue. Wow, cool. Today you're one of today's lucky 10,000. There's an XKCD every day. There's always 10,000 people who learn anything. And you don't know this either. Oh my god, this is such a good one, dude. All right. so there's a story that there was like a math party, or like, I don't know, there was a party, there were a bunch of mathematicians, and maybe it was like some sort of like holiday party or a banquet or something, a seminar, boiling water thing. No, oh my god, none of you know this? So there's a math party of some kind. I don't know why they were partying together, but they were eating corn at a math party together. What's up, Divium? Good to see you. And one person noticed, wait, that's interesting. Somebody noticed an interesting observation. Oh my gosh, that's so interesting. All the algebraists, who knows how true this is or not, all the algebraists were eating the corn the same way in neat rows, turning the corn and eating the corn in rows. And supposedly, believe it or not, all the analysts were spinning the corn and eating the corn in vertical. There's a blog post about this. It's like 20 years ago, I guess. Dude, I'm getting so old. Holy crap. I can't believe you all don't know this. Yeah. I can't tell the rest of the details, but that's it. That's the joke. Like, supposedly all the algebraists ate corn the same way in neat, organized, structured rows, and the analysts were eating it in like a much more efficient manner. Like, oh, this is much faster and much easier to get through this corn. And that supposedly this person's like, I wonder if there's something about just the way that these two people think. Their brains are different. Like, there's these two major camps of math, and the way somebody's brain is wired leads them to eating corn differently, which is so hilarious. Math corn story blog. Analysis versus algebra predicts eating corn. How do you eat your corn? Yeah, this is from 2010. Yep. This is it. I'm going to set this up as a short link. I can't believe... Wait, why are you all deleting... What the fuck? Yeah, no, I don't know what that is. Thank you, Levi, for deleting that. Yeah. Don't spam, dude. Do not spam. What's good? How's it going, Era Portal? Soon, not right now, but soon, you can get a short link to this as, not right now, but very soon. Kohn.jcpractices.com. So, I don't know. It's an interesting blog post. I guess you know what? I should be more clever about this. Give me a second. I should be way more clever about this. Copy. Oh, yep. This. There we go. Thank you, handoff. Yeah. This is the website. Analysis versus algebra predicts eating corn, supposedly. From 2010, August 2010. I like learning about odd connections between disparate things. This is probably the oddest example that I know. Broadly speaking, mathematicians can be divided into those who like analysis, like Math with Ming prefers analysis, and those who like algebra, which would be more like me, or Leo Lectures, or Locke. The distinction between the two types runs throughout math. Even those who work in areas that are far from analysis or algebra are very aware of the difference between them and usually are very clear on which their preference is. I'll delve into this in more depth soon, but for now, let's just take it for granted that this is a well-known distinction and it has meaning for mathematicians. Yeah, so this is just, it's a terrific, funny little story. So find it, just type math Kohn story and you will find it. Not that, there we go. All right, thanks all. Now let's actually get some work done. I should put away chat and actually lock in, but seriously, one of my favorite benefits of live streams is the constant tight feedback loop of interaction with you all. So I can ask point blank, like, what am I doing well? What could I be doing better? Like, what do you all like? What could I be doing better? Am I going on too many tangents, or do you enjoy the tangents? Do you prefer if I were just working like quietly, like Pomodoro style? Because my numbers don't support that. Like, if I look at my numbers, when I go straight Pomodoro style, people don't watch. Like, the metrics don't support that idea. So, I hope that was interesting. Please let me know if that was or not. My goal of this stream today is to film the next episode of my series. Lol, me being the lonely analyst. Yeah, invite your friends. Like, you must know analysts. Who is it? There are other YouTubers. They're just not streamers, as far as I know. Like a struggling grad student. It would be so cool to get struggling grad student in the chat. Or what's his name? There's this one other guy who posts like a lot of videos. He used to a lot. I haven't seen him in a while. Yeah, it's an interesting story. Read it. Like, the whole blog post is interesting. Okay, so we are not doing Gauss's proof this time. And in fact, my episode, I'm going to change it today. This time, I'm going to try a different episode structure this time. What is today the 30th or the 31st? Today is the 31st. Today is episode 7, if I can get it in time. But I'm going to start putting quotation marks around this. I've recently taken the channel numbers out of, the episode numbers out of the title and out of the thumbnails. Because I think it's going to be better for the numbers. just point blank, I think it's going to be better for the algorithm. And not just selfishly, like in terms of how much ad rev I'm going to earn, but more so, it's better for the algorithm because it's better for the viewer. It's more clickable. It's a better packaging for the viewer to invite somebody when they see YouTube recommends an introduction to logic. Like, you don't need actually to watch all the previous videos before this one. You could just jump in the middle. So in the episode, I think I will say, like, technically this is episode 7, and you'll benefit a little bit by watching the others, but you can just jump in here if you want to. And yeah, so this episode, I'm going to start just saying, in the video, I'm going to say episode 7, but not really. Like, you can watch this even if it's your first time. Oh, you were thinking the same thing about episode numbers? Yeah. I mean, if I can get your thoughts on this, I'd appreciate it. My approach right now with that success of the first video is I'm going to go as hardcore as I can. Like, I'm going to start pretty hardcore, in my opinion. Like, this is an organized lecture series, and I want you all to try to watch every week and do the homework and show up to class. I expect you to do the reading on your own and try to run it like the best lecture series that I've taken in college. Because as a aspiring teacher, that's the closest thing to being a teacher, and it's the closest thing to practicing real lecture styles. So I want it to be like as hardcore as possible. Like a 50-minute or hour-long video is just a little too much, but 45 minutes is pretty dang close. And then start as strict as possible and then relax as needed. Or as my skill level gets better, because this is my first time ever doing these, as my skill level gets better, relax and find which assumptions I can relax, or what changes I can make to the standard structure. But at least for now, I do want to keep 30, 40 minute videos. I don't want to do bite-sized 5-minute videos. If I wanted to be a YouTuber and my goal was to get 1 million subscribers, I'd probably just do 5-minute little bite-sized videos, even if they're super authentic and they're truly intro to pure math and they're real pure math bite-sized videos. That would be optimizing for YouTube and the numbers, but that's not my primary goal, as I've talked about in a previous episode. So, I have a channel to kind of promote. Great channel for Olympiad Geometry. Great channel, amazing channel. I think the only channel that has done this much for Olympiad Geometry. Yeah, Levi, I mean, you're a blue mod. Like, I trust your opinion on this. Go for it. You don't have to ask permission. If you want to promote something, yeah, I trust you on it. And if you make a recommendation to like a crypto scam or something that I wish you didn't recommend, then I would just remove your mod privileges. So go for it. Don't worry. Yeah, go for it. That sounds awesome. That does sound cool. I don't have any concern about people promoting other YouTubers, like especially like other videos or something. Because, yeah, you don't even have to mention it out loud in the episode. Just say, like, today we're doing logic. Yeah, Arad, the thing is, like, I want to still invite people to the idea that this is a structured series, or you can treat it like a structured series, because that's awesome. Like, most people have never worked through a structured intro to proofs series. Like, YouTube has enough disconnected tutorials, I think. And one of the things, like, from my comments of the first videos, people were excited that it's a series and that it's going to be ideally structured. Like, one of my biggest criticisms of especially episode 2 was that it wasn't as structured as people expected, which is awesome. But I think taking the episode numbers and like an expectation, like, if you clicked this video and then you found out, oh, I should have watched the first 6 episodes, then you click off, and then that hurts the algorithm score. Whereas if this is the first one that YouTube recommends, you clicked it, and you're in it, and I say, you can watch this, and then if you enjoyed it, you'll benefit by watching the other ones, but it's up to you. Then somebody may watch the thing and then go back and watch the others, and then that's like amazing signal to YouTube. So I'm gonna try to have my cake and eat it too, right? Yeah, thanks, dude. Thanks for the shout out, Ming. I'd appreciate that. Yeah, we all gotta band together, you know. Let's take some viewers away from video game streamers. There's so many video game streamers, so many people rotting their brains who should be studying math. We don't have enough math streamers, and, you know, teamwork makes the dream work, right? Is physics dying? Why would you think that? I wonder if Leo can promote it because content he provides is great. Yeah. Hey, sure. Yeah, this sounds like an interesting channel. I'll subscribe to it for sure. Yeah. I look forward to this. I feel I've always been very weak on my like geometry problem solving skills. I can do like basic proofs of geometry, like high school level average geometry, but like I would not be able to do Olympiad geometry problems. That sounds actually very cool, like something I would like to learn. More than analysis, I'd like to learn Euclidean geometry. Like actually like work through the elements as a series and like run that. I would actually really like to work through the elements very much. After string theory, it's a dead end. Interesting. If you want to expand on that, that sounds like an interesting idea, but yeah, I think I disagree with you. Okay, so what I wanted to say here is no, we are not going to be doing induction. I want this one to be a slightly more bite-sized episode and more single topic focused than some of the previous ones. So my goal is a 30-minute runtime this time. 30-minute runtime and only focused on logic this time. I'll remove some of that other stuff. Or not, maybe I'll just keep it. So this induction example is going to go to episode 8 whenever that happens. Another thing is, I don't want to commit to this, but I'm going to try to do 3 30-minute episodes per week instead of 2 40-minute episodes. So I don't know. I shouldn't commit to that, but yeah. Like, let's freaking go. Like, if people want to watch them and if people are actually watching them, I think 3 30-minute episodes a week would be good on a few different fronts. Okay, then I can delete this page. Let me know your thoughts, y'all, on this structure. So Lang does not do truth tables, which I found so interesting. Is that really? What is this? I think it's spam. I think I'm getting a spam call. Yeah, I don't have anything today. Okay. So I feel like I need a little more intro at the beginning, but the first thing that I want to introduce are, like, Lang doesn't introduce the symbols and notation. He doesn't introduce truth tables and show the connectives. So my thought is a definition, introduction to the logical connectives are the functions, these, and negation. Each takes 2 logic statements and returns a new logic statement, which can be evaluated as follows. And then I'm going to present this truth table. So how do I want this to present visually? I think what I'm going to want is, I'm going to want this table to appear, what in the world? I'm going to want this table to appear Can I get a sharper? Yeah, I can. It's a little too sharp. Is there... Can I get another size? Yeah, I never use a humongous size, so I want something that splits the difference. What size is this one? This is a 1. This is a 3. Yeah, let's get this to be a 2. I don't think I've ever used the humongous one. And I don't think I'll ever use a 1. Well, no, I definitely want a 1 sometimes. I've never tried changing the size of this. This is very helpful. Okay, so I'm gonna want this table to appear. Damn it. Okay. Again, one more time. Okay. Yeah, I mean, I think I'll just do this in one pass. I don't think splitting it is worth it. So I'm gonna want to present that as it's a logic statement that I need to know to tap in the right spots, and then I'm going to define each of these individually. Yeah, I'm going to want it presented in one step. And then... probably just one each. I don't think it's worth doing those separate. Okay, so... also, y'all, please let me know if you think that this is a valuable educational tool or not. Like, it certainly makes it easier for me during the filming of the video to have everything prepared. And then in theory, they're all like lecture notes that I can reuse again in the future. But I think that the primary question should be, is it pedagogically effective or not to be doing all of this like fill in the blank and like pre-filled out work appearing out of nowhere or something. It can be distracting, I think, if you're watching for the little, like you can see that little texture at the top. I can't turn that off on these occlusions, unfortunately. So I'm going to want to present these separately, those two. I mean, maybe one thing is that I could try to get in a better habit of using exactly straight rectangles sometimes. But it gets in the way a lot. All right, so... okay, so the presentation, it's going to be like this. What is your concern with that truth table? I don't remember what specifically it was. The the values are all correct. I'm thinking more about presentation of whether or not one way to present it is a better way than another. Um, Yeah, your goal is to get people to analysis as quick as possible. Mine is like, let's take this slowly, and let me try to indoctrinate people toward discrete math because I'm a programmer, and I think a lot of people interested in proofs are programmers. Like, I personally know a lot of software engineers who would like to learn proofs, but they didn't like calculus. Some of them never even took calculus. Um, yeah, I know. And it's just, calculus is just irrelevant for most software jobs. Fight me on that, it's true. At least most software jobs building SaaS products during the 2010s, which was a huge portion of the industry. I don't know what it's going to be like in the next 10 years, but anyways, what I know is software in the 2010s and logic and discrete math is just so much more important. Okay, so the logical connectives are the functions this, and this. These are symbols, but let's remember that these are functions. So they are going to take two logic statements and return a new logic statement, which can be evaluated as follows. So this is my introduction. It's just going to be, here you go. Like, I'm not going to try to get more formal the way that this book does, like definition, evaluation of a logic statement, and like a little more careful. Like, I think I want some intuition here. So we have two logic statements, A and B, and we're going to do something called building a truth table out of these for each of the different functions. These are and, or, if, then, and not. Okay, so as logic statements, we are taking the assumption, which is historically very accurate, that, or historically it's what we've always used, of every logical statement is either true or false. So if there are two logic statements, A and B, each of them can be true or false, on or off, black or white, 1 or 0. So there are 4 in total, because there's 2 for the first one, 2 for the second, and here are all 4 possibilities. So we call an evaluation of a logic statement the value which is either true or false based on its predecessors or its atoms. It's like it's the statements that it depends on. The simplest statements, like 2 parallel lines will never cross, that's something that you just assume is true and work with for the rest of your system. But anyways, these are going to behave how we would want them to based on these names. Or, and, if, then, and not. So throughout all of Lang's book and historically in math, we've always written mathematical arguments that use these terms, or, and, if, then, and not. And we, in logic, we've started formalizing math to a math in itself, and we create objects, like proofs become objects, and we construct mathematical objects that are either true or false, depending on their predecessors. So these are functions that will return a new logic statement which can be evaluated. So A and B are either true or false, and or, this is saying true or true is true, true or false is true, false or true is true, and false or false is false. So or behaves in the way that it's true if the first one is true or the second one is true, matching exactly the name that we gave it. That's why it's a good name. And what would you pause and think about it for a second? What would you think the truth values would be of and based on the evaluation of A and B? So we want and to be true when both of A and B are true. Otherwise, it should be false. If then, this one is a little trickier, so let's do that after. First, let's do not. Not is going to flip the value of the two. So true, the opposite of true is false. And here I only wrote this for not A. Notice that I'm only comparing to the first column of this table. So not true is false, and not false is true. So maybe it's a little better if I... Oh, geez. Oh, wait. Okay. All right. Here we go. Maybe I make that clear. Not A only depends on A. Not... It doesn't depend on B at all. Okay, now, if then... This one is interesting. If true, then true is true, we would want that to be true. And if A is true and B is false, like, if, I don't know, if x plus 1 equals 2, then x is 0, or something. That's a logical sentence. It's a mathematical sentence that can either be true or false. But that one is false. So, where am I going with that? Like, if in this one, A is one sentence, B is another, B was false, even though A was true. So we would want that connection to evaluate to false. Now here's one that's a little bit of a gotcha, or something that might be surprising if it's your first time seeing logic before. False implies when the antecedent, that's what it's called, right? When the antecedent A is false, then this if-then statement is true. So if A is false, false can imply anything. We think of this as a promise. When A is true, then either B is true or not true. So the only broken promise in this is A is true and B is false. Every other evaluation should be true. I don't feel like I have the greatest explanation of that. I'm just used to it. So if anybody has a better explanation, way to cement LEM for no reason, yeah, you should. That's a good idea. You should teach LEM to intro to proofs. Explaining how each operator is defined. Yeah, this whole lecture today is going to be about truth tables, Locke, so if you want to leave, it's okay, I understand. Okay. In particular on the vacuous truth, why is it needed? Yeah, I have a hard time explaining vacuous truth. And I think that you're right, that it would be simpler to define not. I'm coming at this with a little not bias, but part of the reason that I've built this table this way is that it's really weird. Enderton actually has this being A if and only if B in this table, and he doesn't have not defined as its own, like, he doesn't use not. And I'm like, I don't, like, the way he presents it with all of these others, I'm like, why introduce it as if and only if is its own atomic that you need to treat in itself? So what I'm doing is a definition. The connective if and only if is defined as this. And now this is going to be showing a definition of a new connective based on previous connectives. And then we're going to get okay, so if we define a new connective based on previous ones, this is our first non-trivial. We need to be a little careful about figuring out how this one behaves. So I'm going to switch to this notation, which I think is personally just nicer. It makes it a lot cleaner versus seeing trues and falses. False looks a lot like true with just one extra line in the middle. You can do certainly ones and zeros, and you will see this a lot. I personally prefer to just leave a blank space, but you can, this is your time. You're a hobbyist. You can do whatever you want. You can use whatever notation you prefer. We want to prove that these are the two values, or that this is the valuation of A if and only if B, based on its definition. So we want to prove this. How do we prove it? We prove it with a with a truth table. So we need to see. What I like to do is a proof table, and I'll draw lines for different kind of sections. These are like helper functions, or like my scratch work for proving like a more complex statement. So if A then B, let's look at A and B. If A then B would have this bit pattern. And then if B then A, what is this again? Oh yeah, okay. If B then A is going to be true in the first case, true in the second, because B is vacuously, or like this is a vacuous truth. The only case where if B then A is false is in the third line. So if B then A is false in the third line. Now, if you want, you can just look at the... oh wait, why did I write A if and only if B? That's... Oh my gosh, that's not true at all. This isn't if... Oh wait, no, it is. What am I doing? I'm blanking for a second. All right, so we're defining A if and only if B as this conjunction. You can try to look at both of these, and how it should behave is and. We want to take the and, the conjunction of the left and right of this sentence, and then you can see that both are true in the first and fourth rows of this table. But if you want, sometimes it's very helpful to build a little helper just to see that a little carefully. What we're doing is what I'm introducing here, I like to use L and R for left and right often, many places in math. So let L be A implies B, and let R be B implies A. Then L and R is going to be true in the first row and the last row. And now that is exactly, those are the values that we assign to this as a definition of the if and only if symbol. So I want to introduce those ideas, introduce the notation of like a bit pattern as opposed to T's and F's. Then next, I want to define a tautology. What did Luna do? Kat is here. Yeah, Kat is definitely here. Did she play? Is she playing the video? What's happening? Oh wait, what? What's happening? Everything looks fine. Why was my guitar video was playing at some point? Weird. It's the only way to make certain logical equivalence holds and certain ones don't. I was thinking of explaining it that way too. Like we want to define it as false implies false. If false, then anything is a vacuously true statement. Partly because it makes the rest of math work. You could define it the opposite way, but then it just gets, the implementation of math becomes a little more fiddly, if I understand correctly. JC had logic course, but no sequence style stuff. You still haven't explained what sequence style stuff is, and I don't say skip the standard. I'm just in favor of constructive before classical instead of the other way around. Yeah, I prefer classical before constructive for sure. I mean, that's a more advanced topic. It's definitely a more advanced topic. I'm interested, as I said before, in maybe doing a video in the future, but I think that would be bad pedagogy. Like, that would be a bad way to teach. If you accept proof by contradiction, then falsehood definitely implies any other statement you try to prove, because you already have a contradiction up your sleeve, so to speak. Oh, that's a good way to explain it. Like, you would want that fact to, if you want to use proof by contradiction, you would definitely want vacuous truth or something, right? Thank you for moderating. Take care. Take care, dude. It makes contrapositive equivalent to the original implication. Oh, thank you. And it makes converse not equivalent to the original. Oh, does it? Oh, neat. Oh, that's cool. Wait. Yeah, certainly. Okay. So you're saying if in another world we had if we defined a different implication operator, which I'm going to give like a squiggle arrow or something, and we define this as, you're saying, true and true, true and false, or true, false, false, true, false, false. You're saying this one would still be true, this one definitely is false. Now, if this one is false and this... Yeah, okay, so this would be our new operator. Non-vacuous implication or something, then B squiggle imply A, would still be true in the first. B squiggle implies A would be false in the second, false in the third, and false in the fourth. So then, oh, that's cool, dude. Thank you. That actually helps a lot. Because then we can say that anytime that we have a statement, then immediately B squiggle implies A is always true. But in math, we don't want that. We want converses to be false, even though the forward implication is true. Like it just, as a model, as a logical, this logic model models mathematics, like the math that we've done for thousands of years. It's a better model of mathematical arguments that already exist. Awesome. That's super cool. Luna is definitely pressing stuff. Ah, neat. Oh, dude, this is such a cool exercise. I'm going to credit you for this, Ming. Thank you, dude. I might give this at the end. Exercise. Imagine that we don't have vacuous truth. Vacuous define a new operator find one or more tautologies which no longer hold, which are no longer tautologies. When replacing right? Do that. I think that's a really good exercise. Nice. I think that this is just a fantastic way to... I'm going to credit you for this one, dude. Thank you. Let me know if you don't like this paraphrasing. I mean, you just gave me the idea, and the idea is credit to you, you know. Okay. But you didn't phrase it exactly this way. Cat is here. Cat is definitely here. Yeah. Converse, contrapositive equivalence and converse non-equivalence fall apart. There's only finite. You can test each one out. You're welcome. Thanks, dude. I give contrapositive as another example in this. Yeah. Okay, so back to constructing, no pun intended, my lecture notes. Okay, so my next goal is, and this isn't how this book is structured. This is just inspired by this book, actually, and I'm wording things in my own words, but I'm following it and at least taking inspiration from it. And none of this is in Lang, which I think is really a mistake. A tautology is a logical statement which is true for every truth assignment of its parts. For a tautology A, we write turnstile A, double turnstile A. Let's take out the yellow out of this. I think that should just be white. For anyone who's curious, people will just say call this the tautology symbol, but there are multiple tautology symbols. So if we want to be more precise, this symbol is the double turnstile symbol. For example, my first example of a tautology, which I know Locke is going to love, the law of excluded middle. This is a tautology. So, how do we show that this is a tautology? Before I show it and prove it mathematically that it's a tautology, I want to start with examples. What does law of excluded middle mean? Really, this is the mathematical idea and the fact that we use during proofs by contradiction, which we introduced in the last lecture episode. For example, I mentioned, but haven't proven yet, that the square root of 2 is either rational or not, right? Either the square root of 2 is rational or it is not. Another wonderful classic proof by contradiction, there are either infinitely many primes or there are not infinitely many primes. One of those two have to be true. You assume one and then derive a contradiction, therefore your assumption was false. So either the square root of 2 is rational or it is not rational. Either there are infinitely many primes or there are not infinitely many primes. Either the cat is alive or it is not alive, right? It would be quite paradoxical if a cat were both alive and not alive or something else. We want to think that a cat is always either alive or not, and it would be very strange if not. Now, this isn't the reason why, but this last example, you may or may not get the reference on that. It's not the reason why, but the reason that I'm choosing the law of excluded middle as a tautology is that there's actually modern work, and some people reject this specific example as a tautology. By the way, here it is. Exercise to the reader. Think, before I showed that, how would you write the tautology? Something is true or not true. There it is. There's modern work of people building a new style of mathematics called constructive math or intuitionist math. And we try to, where we can, um, use proofs that do not rely on this fact. Like kind of relax this as an assumption. But it's not the classical approach, and in this course, we're going to stay with a classical approach. A is either true or false. So we build this truth table. And what does it mean, again, to prove that this is a tautology? It must be true for every truth assignment of its parts. So right now, I've just shown the truth assignments of the parts of this compound statement. So we want to see that it is true for every assignment. Well, this one's fairly easy. Notice I didn't write the helper on this, but we have either 1 or 0. And in the second case, we have 0 or 1, true or false. I don't want to mix these two. I'm mixing within the same example. Let's not do that. That's a bad idea. If you don't, so let me say this is true or not true. And this one is true. False or true. I will definitely mix in or, the word or, and frequently, especially because I'm a programmer, and in a lot of programming languages, we like to just use the words or and it makes your code read like English. I think Lang would really like these modern languages that allow you to just say or and, because he really likes English sentences. Okay, so in any case, now we see in either case, no matter the truth values of A, of its parts, which is only A, every assignment is true. So this, we say, is a tautology. It's tautologically true that A is true or not A is true. We write that. Next, exercise. Show that and is associative. I want to show and is associative. How do you prove that? Luna! On this example, I think I will just move more quickly. Let me just temporarily get the largest. I don't want to work this entire example, but I want people to be able to pause the video, try it yourself, and then here's the answer, and then move on. I'm not saying that it's the only way to prove those sentences. Like, it's obviously not the only way to prove mathematical things. And I should I've been wanting to say this, and I'm glad I'm getting the reminder right now. When I'm showing examples, and talking about, like, by the way, fun fact, some people are trying to build math without this because there are certain advantages, including computer implementation of math. It's much more satisfying for a very long time in math. It's always been considered more elegant and more desirable to prove something without contradiction. And it turns out that right now, if you avoid using this tautology, you can implement math with type theory and other things, but we're not going to get into the details. I just want to give examples that classically, the classical example, like both of these are classical first examples of proof by contradictions. There might be other ways to prove it, but one way to prove it is by contradiction. Okay, so there's our first exercise. What does associativity mean? This is a purposely vague sentence. What does this sentence mean? Show that this is associative. Let's remember, what did associativity mean before? The first time that we saw associativity was this. So, we say that the plus symbol is associative. Then maybe here, in this context, we replace that symbol and A and B and C. Do we write equals here? No, we don't have an equal sign in our logic system that we've built so far. What's the closest thing to equals? It would be the by implication, the double implication, if and only if. That is the equivalent right now. No pun intended. So, we want to show, our goal is to show that this is a tautology. So there's the first hint. And this gives the viewer a chance to pause the video and try to work from that hint. And then, okay, so let A, B, and C be formulas. And our goal is to show this, as I just said, that this is a tautology. And here's the solution. So, next, De Morgan's laws. We have two laws, and this is one of the most useful things you'll ever learn from this entire series if you ever are a programmer. This one you use all the time. Just all the time. All the time. It's like a distribution of the not operator. How does the not operator combine with the conjunction and disjunction with and or? So, how does not interact with and how does not interact with or? It turns out that the negation of a disjunction is the conjunction of negations, etc. All right, and then here is the solution for the first one, and then the solution for the second one. Let's move on. Cool. So that's an exercise. Now prove contraposition. So again, we want to show that this is a tautology. Now, I'm just going to immediately show this one. And then I would say in the lecture, this is one that's incredibly useful in proofs, and we use this all the time. To prove a statement, it's often easier to prove the contrapositive of the statement instead. So there. And then a follow-up exercise. Here's something a little more challenging. Credit to Math with Ming from the live stream today. Imagine if we didn't have false implies anything. Then what would happen? I said earlier that math would break. Can you prove it? What did I mean specifically by math would break? Let's find a tautology that is no longer tautologically true. Let me read. Let me catch up in chat. Any thoughts? Any feedback? Is this good pedagogy as a little 30-minute demo or a 30-minute lesson on intro to logic? Anything that you think is important that I'm missing? And I'm not going to do any sort of non-classical logic. I'm pretty sure that translation requires double negation elimination. I don't know what translation... to translate a proof of contrapositive to a proof of the original. I don't know, just pragmatically. I don't remember specific examples. Maybe Math with Ming does, but I just remember very frequently it's just pragmatically more... It's easier to convert a theorem into its contrapositive and then prove the contrapositive. That's just bread and butter. It comes up all the time. I don't remember specific examples. In theory, yeah, maybe you can rewrite everything and implement stuff in Lean or something in a functional programming language. But in practice, classical math, it's everywhere. I see. You just sometimes question why. Yeah. Well, try to find next time that you see it, even next time that you see it, try writing in English sentences. Try translating the proof in English sentences and compare your proof that was translated to the one that you're skeptical of. That's an easy one. Next time that you're skeptical of why use the contrapositive, try it and see what happens. I haven't done that, but I don't know. My intuition is that it would just make for an uglier proof. I don't know. Okay. I think I can do all this in 30 minutes, and I don't think I'm missing anything important right now. There's certainly a lot that's in the book. One I think is valuable, even if it's not, even if I wouldn't say it's important. Maybe let's undo that. Let's get a new page. And I gave like a non-trivial first example first. Now I want to offer this to the viewer as an exercise. Prove that it's tautologically true I'm gonna try to give this as like a little more clever or something. Prove the equivalent statement of negative A equals A. And this was Lang. We proved this theorem in Lang, and we proved it. The negative of a negative is the positive. Lang N4. This was theorem N4 in Lang. What would the equivalent be in logic? It's not a direct, exact one-to-one, but there's a parallel idea. And double negation is, yeah, I think that's a good. The equivalent is that it's always true, or that, double negation is equivalent to itself. It's quite similar looking, even. It's quite similar in a lot of ways. So, we'll do a truth table. False implies anything. And then, wait a minute. Oh yeah. All right. So, what am I? Did I do? Oh, did I write something down wrong? Wait a minute. Slow down. What went wrong? A 1 or 0. not A is 0 flips to 1. Right, not A implies A. Oh, I was comparing not A to not A. I see. Okay. So if you compare 1 is forward arrow 1 is 1. And then 0 forward arrow 0 is also 1. And then QED. Seems... Hey, thanks, Arad. I appreciate that very much. A is sufficient for B, which also means B is necessary for A. I don't know, man. I think you need, like, again, dude, extraordinary claims require extraordinary evidence. Lots of mathematicians have used, and lots of textbook authors have proved theorems with proof by contrapositive, right? Like, this is like a pretty, like, higher level reasoning skill that we need to work on. Like, a lot of textbook authors have done that. A lot of giants that we're standing, on their shoulders of have done it that way. So you're correct to question and try to understand why. So if you think that you can translate a proof, then try it. Try it, and maybe you're right that you can rewrite everything, but did it clarify the argument? Was it better than proving it through the contrapositive? Like, you need to bring to us a specific example where you think it's better. Like, yeah. Like, one thing is computers. Like, if you're implementing something in Lean or something, yeah, you want to minimize flops or, like, just minimize code or something to avoid having bugs in the code. Like soundness of a kernel or something. But if we're talking about human exposition and clarity of argument, then you need to have examples of what the benefit is that you're proposing. Why will we use complementary counting when we can count directly by those fundamental counting techniques? I'm not sure what you're referring to with that one. Subhajit. All right, I think that this is enough. I think it's plenty, and I don't think I'm missing anything, like, super important. Let me flip through the book. I mean, I could just write down some other tautologies that are valuable or something. Excluded middle, contradiction is the negation of excluded middle, contraposition, exportation. I don't feel like exportation. I think the distributive laws are really cool. And that's like a really nice example to leave without a proof on the screen. Like some follow-up exercises. maybe before this one. I think another good exercise would be prove. I'm going to go a little further than Enderton. Not exportation. Exercise. Find and prove the how do and or connect? Another exercise could be prove contradiction. This one I want to give explicitly. It's tautologically true that it's impossible to have A and not A. I may have a note that in some places I haven't used parentheses where you may want parentheses or something. Try to construct the parentheses conventions, but that's a little vague and hard, I feel. Yeah, right. The multiplication versus addition doesn't match exactly the distributive laws. Like, if you think of them as multiplication and addition or something. Yeah. Yeah, because there's two. Let's. There's two distributive laws for or and an or. I think this is a good amount for a video. I'm gonna pee, take a quick break, come back, do a little more lecture note prep, but I think we're very close to filming the thing. I don't think I want any more. Yeah, be right back, y'all. BRB. Okay, hello. We got to wrap this up. I'm going to try to hurry up now. So, intro to pure math. Hey, enjoy your tensor stream, dude. Good to see you, Ming. Thanks for stopping by. Let's see. So, I'm thinking I want like a bolder, boom, intro to pure math kind of intro look like that, and then reveal these bits after. As much as I enjoyed the Kohn discussion, let's remove all this. Intro to pure math. You can get to the whole playlist at mathcanbeahobby.com. We're so close. We're almost there. Just gotta do a pass, making sure all the things are turned off or turned on appropriately. I'll be showing this, and then I'm going to scratch out induction, and I'm also going to scratch out episode 7 or something, and just briefly say that we're going to try to treat each episode as standalone episodes a bit more, and I want to hear people's thoughts, any kind of suggestions people have about the structure of this series, especially in the early days. If I can get people involved as much as possible, that'd be awesome. In the second page, I want to go back to a previous idea of having like a very brief intro that's a little less mathy and a little more social, which I think is standalone episodes feels like a weird idea for a series. We all talked about this earlier, and Arad and others agreed that they are part of a series, but you can just jump in the middle, and I'm gonna invite the viewer that they will get the most out of this if they watch the previous ones, but this episode can stand on its own. You don't have to watch all the other ones beforehand. I think that's going to just be significantly better for my algorithm metrics and signals to YouTube. Like if somebody gets recommended this video and it's episode 7 and it says episode 7, then somebody doesn't click it because they think, oh, well, I haven't seen episodes 1 through 6. I need to go find those first. Or if somebody does click it and then they see, oh, okay, I think that I really do need the other episodes, then they click away early in the video, and then that really hurts retention and all those signals, which are important. So, yeah, I really think on a few dimensions, but really regarding the algorithm, like, I think it's a good move. But then also for the viewer, like, I do want these to be a little more standalone, and maybe more importantly, like for teacher to be able to link this to a classroom, like, oh, this is one of my favorite introductions to logic on YouTube. Watch this. You don't have to watch the rest of the series. Like for somebody to be able to recommend it to somebody else, and for it to not feel like, you know, you're missing out if you haven't watched everything else. All right, and then I wanted a couple of quick notes. Today is a practice session, so we're going to be doing a little more practice, even though in this one I am introducing some new concepts. Every week I'm posting one that's more theory-based and one that's more practice-based. So today we're going to be seeing more examples, more exercises than a theory video. Another change in the series is that I'm going to aim for 30 minutes as opposed to 40, 45 minutes. And I want to quickly give a couple shout outs to a couple specific comments that are very related and things that I'd like to highlight. Where were these? Yeah. This one. Here's one of the two. And then the other one is this one by Saba. I think both of these are just like really freaking amazingly cool comments. What else? I feel like there's got to be another comment or two that I wanted to highlight in a video. Let's just grab in one from the first video. Oh, I didn't heart this one? Oh, I haven't responded to it, that's why. Okay, I have to respond. Luna. Yeah, you're reading the Python script one? Yeah. It's incredible, man. I'm just like so like that's an achievement as a YouTuber that I got somebody to practice Colette's 27 and somebody else wrote a Python script and they've ran it for hours to that's so cool. That's so interesting. Let's get this one on screen as well for this video. There's so many comments that I want to take a little bit of time in the videos to respond to some, because it's just much nicer to get a response from a video and see a verbal response. It's easier for me to verbally respond to some comments, and then I don't know. I feel like this could make for an interesting little intro to the videos that don't require mathematical. Yeah, like for some people who are just here for the vibes, they might stick around and just watch a little bit in the intro before we get really technical, which might sound like I'm just like trying to game the algorithm or something, but I just think that can make a better video. Like that just makes a better video, honestly. If you add like some of these types of social elements, like how can I be using these videos as not just a one-to-one, just somebody filming a college lecture, like encouraging interaction and community, discussion. I think that that's a way that we can use this format in a smart, effective way. So I want to highlight these comments and just get them on screen. So yeah, I think I'd do both of these together and then talk about this next one after. And I'm going to speak of that one as just an example of one of many similar comments. But this is one of the top upvoted, 561 votes or likes on this one comment. So I think it's pretty cool. I'd like to take a little moment, responding to a couple of these. And in particular, this one I'm just so proud of. Like, this one is amazing. Like, that somebody discovered this. And I want people to find this fact, because I don't think a lot of people found this hidden little Easter egg that I left in a previous video, in the last practice session specifically. Okay, so then let's give just a little tiny let's give this that'll give me just a moment to introduce the topic of today's video, and then I think that we're ready to just get going. Okay. I also need to, I had a mental to-do to make one change here. So That purple looks absolutely horrible. Can we get a higher contrast? This one. Oh, yeah, I keep coming to this point. This is going to be a pain in the ass to do, but I think it'll be worth it. Because everything gets harder to move around if I've already put all the occlusions everywhere. But somebody had a good point that maybe we could define, maybe we could define not before defining the connectives, the other connectives. It's just objectively kind of a simpler one, right? Yeah, now I'm like moving the entire occlusion. I'll just have to rebuild everything. Which is okay. These can move. What just happened? Okay, so those are still enabled. Now this one, nope, the occlusion is gone. this thing only depends on A, it'll be better to explain that one first. What? Okay. Luna. You're so cute. You're so cute. You know what I'm going to do? I am actually going to do this as 2 separate occlusions. Maybe I'll just have to film this tonight. Damn it, dude. Yeah, I think I can't get this done today. I kind of like just keeping the yellow frame before showing stuff. Just have the yellow frame prepared and already visible. Okay, on the occlusions here, let's there's a lie where I say everyone takes 2 logic statements. There's one, I'll just explain that was a lie verbally. So I'm going to turn on A this way and then B this way and then reveal those after. And our goal is to fill out this truth table. So we're going to find the values of each of those connectives depending on the values of their atoms or their priors. What's the best word for that? On their parts. I like the word parts. And then I'll say, I lied. There's one that does not require 2. The not operator only depends on 1. So not A will just flip true to false. Luna's in the way. Luna's in the way. Oh, geez. Oh, goodness gracious. Okay, so let's delete that and rebuild. It's too low. Okay. And yeah, to make a Python script for some math object, I did that when I learned group theory, and I was learning about subgroups, like a Java program. In my case, I wrote a Java program to find all the subgroups of a group, of a cyclic group. Luna, you're so cute. And like it showed not just the, I don't know if it was a cyclic group. I think I did this for the dihedral groups. I showed the group multiplication table. Like I showed the whole group table. And it was a program that would build that. That was definitely me. Okay, so now these things are all tappable. Let's just do this in one thing. But the last ones will have stars to remind me to talk about the fact that those last ones are interesting. Okay, so now I think that this page is done. The connective if and only if is defined as this. There's like a little artifact over here. A couple of artifacts I don't love. Oh, this is such a pain in the butt. I'm gonna delete that. How can I fix this without rebuilding everything? Is there... I don't think there's a way. Okay, this is such a hat. No. Let's just leave it. It's... Oh, no, it's not going to take that long to redo this one. Okay, there we go. This one would already be on, so that issue is not a problem. Wait, where did it go? What happened? The fuck? Oh, something got undone. No, this one, I'm going to go back to what my first thought. My first instinct was... should be black. And... the yellow frame shouldn't be visible at first. Ah, shit. Okay, there's that little artifact. Luna, 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 Luna. Oh, there's two little yellow... that's so annoying. Okay. Okay, here we go. Here we go. There we go. Great. Anybody still out there? Is my chat behind? Not doing push-ups today. I'm sorry, everybody. I apologize. I don't have time to film this. I ran out of time. Bummer. But I got my notes done. Wait. At this level, we've already seen how many. We've seen several. At this point, I'm going to start going to white tables. Even though that means I'm going to have to rebuild this freaking thing. It's just like a little distracting, I think, and not that valuable anymore to keep highlighting those as yellow. Can I just do it in place? Can I just do it in place? Oh yeah, and I wanted to just reveal. So that means I will be this is all going to be one reveal. I think it's a little distracting to switch to the word or there. Oh, I don't have the cute square. Python script? Pythons can't read or write. Yeah. Yeah, they can't. They definitely can't write anything in script. How's it going, dude? What's up, man? Doing truth tables today because Lang doesn't do any truth tables at all, and I think that's a little silly in a intro to proofs book. How can you teach proofs without proof tables or without truth tables? It's a little crazy to me. We show that this is a tautology. And the proof's right there. Next, show that this thing is associative. No truth table's preposterous, but oftentimes they're a crutch. Yeah, you want to learn them at first, just while learning how to write proofs, and then this is a great point, a great conversation point that I'm gonna try to work into my video. You learn these, and you get used to them, and then you forget them. Like, you want to be able to analyze a statement and parse it and understand the way it would be written, but you don't write these out during mathematical proofs. So I suppose Lang wants to try to get people to read proofs without this process, that it's a crutch. Yeah, I think that he's just opinionated that it's a crutch in some way. Yeah, because he has these ideas everywhere in the book, but he doesn't write them out as a formal object in themselves, like logical sentences. I'm sure he thought about it and just decided not to. Okay. But most intro to proofs books will include this, so I think it would be a disservice to the viewer to skip them. And they're like, understanding this is quite important for software engineering. Let's get the one in this occlusion. Same thing with this too. What do you think of this presentation style, Zombie? I feel like it's maybe kind of attention grabbing or something. Like, it might be a little more, I don't know, retention. Like good for attention, but it's not just like as a YouTuber, but as a teacher, I think that this, like, that's a good thing for anybody. Like like, I think that it's a little attention gathering, or like gaining, what am I looking for? Like, I think it's kind of engaging. Presentation style being like, I'm about to film a video with these prepared notes and like a lot of this fill in the blank sort of style. And I'm like popping up prepared notes. I mean, I've definitely never seen a math lecture, presented this way. Especially something with a lot of color that's just meant to be like accent colors. Anki style. Yeah, I'm glad that you get the reference. Yeah, definitely. This is very influenced by, like, I know some people in medicine and stuff, and they use Anki all the time. Like, yeah, occlusions. Like, I use the term occlusions, and it hasn't come up yet in my videos, but I recommend that people make flashcards. Like, actually make Anki flashcards. Like, I could build that out of all of this, out of these notes or something at some point. Yeah, I think it's a very effective way, but this way I can have all my notes prepared and it's still a live performance, because I find it so important that everything is live and unedited. Just live, unedited, single take performance, even if it means a lot of preparation of lecture notes, but it's still a single live performance. Just like being a teacher, like in a classroom. Like, theoretically, this could all be done in a classroom. A classroom with a TV. I just need a TV and Wi-Fi, I think. Or theoretically, maybe a TV and a display cable. Like, I'm a little worried that some bits might be actually distracting for some people. Like, I find it a little distracting that there's like these little, like, if you look closely, if you're really looking closely, you can see the top border of the occlusion, right? That like thin gray, but you have to be looking closely. But for some people, that might be really distracting. I think I would notice it a lot, like especially in like some of these heavy areas where there's a lot prepared. Like over here, it's meant to be, I don't know how well you can see it. It's meant to feel very simple at first, but then like, oh wow, there's like a lot actually over here. Like in this, I'm going to be talking law of excluded middle. There's all these facts that pop up. I think that can be distracting. I like one takes, big fan of recorded uni lectures. Yeah. And for me, if I'm practicing to be a teacher, I think it's very important that everything is a one take. A one take performance. I suppose I should be writing that this is a tautology. And I guess I could show the mathematical fact and then name it. This is called contraposition, or proof by contrapositive. We'll prove that this works based on truth tables. And there it is. I'm going to be inviting the viewer to pause the video at points if you want to work these exercises. That's a benefit of a YouTube video. You can pause. I'm going to give you a second or two, then show the solution, move on to the next one. So here are some more exercises. Let me just, I will make a technical error here if I don't remember. There's no proofs on these. Here are two simpler exercises, and then here's another one. Credit to Math with Ming on this one. Oh, shoot. Like, I think that you can be, like, actively engaged in thinking, like, predicting what's in these blanks. Like, somebody can quickly read this. They don't have to wait for me to write everything by hand. So, like, I still get some of the benefits of the fact that writing something by hand on a chalkboard requires you to move slowly, and people are actively thinking as the professor's writing something on the chalkboard. This tries to get some of that feature, if that makes sense. All right. And then I'm just going to give my thank you. And I think I have a new person to add to this. Many freaking thanks to all of the channel supporters who are helping make this possible. Let's see. Where are we? Oh, no. Okay. Let's see. Xavier. That's Xavier. Do I have Edine? Yes. Do I have Yu? I don't think so. Okay. One, two, three, 1, 2. Most of these people are at the $1 tier. Like, it's not like I'm earning like an insane amount. Like, if everybody here was paying $10, I'd be very happy. But just the symbol that, you know, people are willing to part with any amount of your hard-earned money. Like, if YouTube would let me set a lower price, just 50 cents a month, I'd do that. Yeah, I appreciate it. Dinshi. Luna's in my way. Luna's in my way. She's so cute, but go away. Oh, sorry, Luna. Dinshi 0703. Life of Sanjay. And let's see, how did I do this last time? Oh, I'm putting this in the thank you page and then copying it over. So now this is reusable. Dang, okay. I wasn't able to get everybody in that one, so we'll just have to do that again. It's a good problem to have. Let's try again. Shoot. There we go. Cool. All right. Well, this is a perfect ending right now. Let's just let's call it a day. I think I'm all done. Oh, wait, no. One last thing. I do need to actually copy this over. Okay, so if I grab from the bottom. There we go. I think I'm all done for today. Everything is pretty much completely ready. Yeah. Yeah, I think that's going to work. All right, thank you all. Many freaking thanks to all of the channel members, everybody who's leaving comments, just everybody who's here and helping give feedback on my presentation, on the content, as well as the visual style, and just like freaking everything here. Thank you all. It means a lot. I don't know what's up with this weird white thing. Can I delete that? Why did that get so strange? Okay, I'll have to do that occlusion again. That's okay. No problem. Wait. What? Sog? I'm missing a bunch of people in this. What happened? What happened? What happened? Oh, it didn't all fit in one copy? And this one does not have that weird white artifact. Okay. Instead of doing it the way I did last time, let's copy the pages. How do I copy? No, copy 2 pages, please. Copy both pages. Okay. Buggy, it's super buggy. This app is buggy sometimes. Delete all that. Paste. That didn't work. Why didn't that work? Oh, why didn't that work? Why didn't that work? I gotta go. Let's just try again the simple way one more time. Copy. This time, yeah, we got all of the Luna channel members. Okay, if I'm zoomed in, that'll be fine. Great. Cool. I think I'm all done for today. Thank you all for hanging out with me while I prepared my lecture notes. It really, really helps to have your company while I do this. As always, feedback is a gift. Oh, I have an idea. Feedback is great. I like the exclamation mark, but decisions. What the hell is happening? I'll do feedback in 2 parts. Just invite people to leave feedback in the comments section or DMs or anything, or in the live streams. And then if anybody ever preferred to give anonymous feedback, I even have a Google form that somebody could use if they preferred. All right. Sick. I want to reword that, but I'm not going to. I'm just going to resist. Thanks everyone for watching. It was a freaking pleasure. Yeah, thanks for watching. Like and subscribe and share it with a friend if you have any super nerdy friends who would like a live stream or a series on pure mathematics. Thanks for watching. I really gotta go. I'm so late. Bye.